So with that, I think we will turn it over to Jayant Sharma. He's a product manager at Oracle. Jayant, welcome and thank you for joining us today. And Nick Salem, I hope I pronounced that correctly. Nick,
that's right.
You are a distinguished engineer at NEUSTAR, and thank you so much for joining us. We really appreciate your time and all the great words of wisdom. And why don't you guys kick us off with telling us a little bit about your background? That would be great.
Thank you, Tammy. So, well, actually, yes, Nick, this is the, gives me a chance. I've never been on a panel with a distinguished guest before, so thank you for joining us. And what we're going to talk about here is just continuing with, as Maria was pointing out, what does the converged database do for you and what are the benefits in it? And we'll be focusing on the spatial part. I'll try and keep my portion short and sweet because we really want to hear from Nick, who's put all of this into great practical use. And Nick, it's amazing. You spent your 20 years collecting 20 certifications. That's quite an achievement. So very briefly, we'll first talk about, well, what are these spatial features? Why are they useful? So why are they there along with the JSON and the graph and the other features? And how do you use them? And then Nick will go into much greater depth on why and when they're actually used. So the first thing to know about spatial, actually, well, the first thing to know about spatial is the first law of geography, which is things that are close to one another influence one another. And that is going to be the core. And that is what Nick is going to expand on in much greater detail. So things that are close to one another influence one another. Are my customers in a particular cluster? And it's fundamental to understanding where your customers are coming from. But there are other uses of it too. Someone talked about wine. Can I ship wine to this address? Well, it's in Massachusetts. No, you can't. You can only buy local. You can't have it shipped to you, or at least that was the case. So understanding how things are related, how things are connected. Are they in a certain jurisdiction? Is my tax rate different? And or do you have no taxes at all, and that's why you're living in New Hampshire? So what is it that is involved in answering these questions? The first step is actually representing that information. The locations of customers, the locations of your assets, the locations of where something occurred. Those may not just be simple discrete point locations. Your assets may involve things like your network. Where's my water pipeline? What's my road network? Where are my utilities, whether they are above ground or underground? And we talked about, can I ship wine there? That's a jurisdiction. Those are things like, also known as polygons in the spatial terminology, but a jurisdiction, a sales region, a flood zone, a tax zone, an administrative boundary like a county or a postal code. So being able to represent that information. But all of it is not necessarily that's the way it comes. Sometimes what you get more and more often these days, it comes from sensors, whether that's aerial photography, traffic camera, or other sources. So storing that information, extracting the features, then being able to do things with them. And much more recent development in that sensor-based information, you see it on your Toyotas, on your Teslas, for example, that say you're too close to an object or that is a street sign, is something known as LiDAR. Send out signals, get back responses, quickly build up an idea of what is around you and identify things in that. And then you want to do analysis on this information that you have extracted, whether that's on your network. Can I get there from here? How long will it take me to deliver this pizza or the sushi that somebody just ordered? And in order to do that, you need to have the capabilities to first figure out where does this order have to go. Somebody typed in an address, so you need to convert that address to a location on the network. That's known as address geocoding. Given an address, get back a lat long. So we know that we can represent all this information. How exactly is that done? It boils down to simple predefined data types, as Maria and others pointed out, and thank you, Roger, for giving the JSON example. It's represented as an object known as SDO geometry, which can represent things like a jurisdiction or the outline of the boundary of a country, and then SQL to query them. So find out, given this GPS location that I've got, where was it? It's in a certain country. Is it in a certain tax zone? Is it in a certain jurisdiction? And all of these functions, there are hundreds of them, and so we're not going to go into those details, but the key ones, and Nick will talk about them, but the key ones are essentially the following. The first is find out, is something in an area of interest? Is something reachable within a certain time? Is something in a cluster of interest? So how do you start with what is this something? You have an address, for example, somebody entered and said, I want the sushi delivered at this address. So convert that into a location, associate that location with your street network so that you can find out how to get there, associate that location with a tax zone so that you find out whether or not there's a sales tax to be applied on it, etc. But as we said, that information may not always be as discrete as that. You may have a UAV flying over and collecting a lot of information, drones, for example. You still want to work with that. So store the source data because it has multiple uses, extract what you need for a particular use case, whether that's doing things like precision farming to understand yield, or whether that's things like understanding, what is the road network, where are the cell towers, and being able to analyze, if I put a new cell tower here, will it help, or will it be in a shadow and be obscured by buildings, so there's no point in putting yet another cell tower here at this location. And a lot of things that happen are, and especially when it's related to sensors, are connected by networks. So being able to analyze things on a network, just if you are, for example, you may have a location that is 2 miles or 5 miles away as the crow flies, but 15 or 20 miles away if you have to get there by road. So, saying that is my nearest location is not going to be good enough, and you won't be able to deliver within your promised 30 minutes, for example. So you can represent it, you can query it, and then how do you actually use this in all of the modern day development? And that is the basic point here, is giving that capability and then giving all the standard programmatic and other interfaces. As Roger pointed out about the simplicity and ease of use of Apex and orders together to give a REST interface, or the microservices, Paul and Quasi's workshop says, here's how you can use it with Python and Node.js, etc. So that's what we enable. We make sure that all of these interfaces work with all of the spatial functionality that is of interest. So the most often used one, and Roger gave an example too, is JSON and the spatial flavor of JSON known as GeoJSON. And the reason you have this geo part is when you get back this text and you've got this keyword over there that says coordinates, which indicates either a lat-long location or an outline or a boundary, it's knowing how to interpret that. And that's what the GeoJSON does. It tells you exactly to understand, you get a document which says GeoJSON, you know exactly what it represents and exactly how to extract things of interest from it. And that's what you use when you're using it with ORs. So you send a request, you get back a JSON response, but more importantly, there are two things. First is you don't have to do anything special. ORs understands it, and you can ask for that in GeoJSON, or you can ask for it back in just standard JSON. But the important thing is that you can add the bind variables, as Roger was talking about, right? He gave a bind variable example for the query about finding great sushi. Similarly, if you were to say, I want to find great sushi for zip code 89112, or things that are within 5 kilometers from that. So you make that request, you get back that GeoJSON, you can view it on a map, as Duncan's example later will show, or you can just consume it and use it in a Apex report. You can actually even use it on a map in Apex. But let's move on to what was the really interesting part, which is, and we are lucky here to have a preview of a much longer, much more detailed session that Nick will be doing later at the TechCast. So Nick, you can take over from here.
Yeah, so there's a TechCast Days that's hosted by the Analytics and Data Oracle user community, and that's going to be in about a couple of weeks from now. And it's really a three-day event where there's a machine learning day, there's a spatial and location intelligence day, and Analytics Plus day, and you can register for all three of them or one of them. But if you're interested in learning more about spatial location, there's going to be some 3 really great sessions on July 8th. We're going to have the scalable location-based contact tracing with APACs. It's a great session. Then we're going to have another session on tracking hurricanes and using Oracle Spatial Graph technology to track hurricanes and how they affect a really interesting customer use case. And then I'll be also doing kind of a much more detailed session on kind of how NEUSTAR uses a spatial to kind of handle or take care of a lot of geo marketing for our customers. So definitely, if you're definitely interested, I definitely encourage you to check those sessions out. I think Giant gave a really good overview of some of the Oracle spatial capabilities across different techniques. It's a really rich spatial and graph and spatial itself is a very rich capability that can handle so many different parts of. You can do so many different things. There's so many different use cases. The use case that I'll be kind of mostly focusing on is kind of spatial and how it supports marketing applications. NEUSTAR manages a data and application environment for just handling geo-marketing solutions that help our customers. And that's going to be my focus in this session. So just quickly about myself. I have many years building geospatial enterprise application over the years. I've had 11 years at NEUSTAR, and then prior to that, about 10 plus years, 10 years or so at Nielsen Claritas, building geospatial enterprise applications. A lot of experience in the spatial arena. And one thing that's been really helpful for me throughout the years is gaining expertise in all the major core database technologies. And that's why John mentioned the certifications, but getting certifications in RAC or Data Guard or spatial data warehousing, SQL Advanced SQL Database Administration, all those kind of help me understand how things work together, how to maximize throughput in an application, how to strengthen security, how to maximize high availability, and squeeze as much performance out of the system to kind of solve the different customer use cases. And spatial and graph has been a really powerful feature, a rich technology stack that we've been able to tap into and leverage to solve a lot of things. So I really enjoy participating with the spatial SIG. and seeing how we can further grow collaboration and exchange of ideas in the community. So that's something I kind of get involved in as well. So the kind of the agenda for today, and so I've got about 10 slides on NEUSTAR, and that's going to give you kind of a gist of what what the company does. It's a pretty amazing. We do a lot of amazing data. We have a lot of access to amazing data, and the service that we provide is pretty very interesting and cool stuff. So I'm going to try to go through kind of the foundation of that, and then going to try to focus more on kind of each of the spatial use cases that we deal with and how we support our different customers, how NEUSTAR kind of helps different clients solve different needs, and how spatial behind the scenes is used in different scenarios. So just quickly a little bit about NEUSTAR. It's a good sized company. I think it's got about like 1,500 employees. And it started like over 20 years ago in kind of mostly in the telco space, but over the years it started moving more into analytics and security, and that's really where all the investment and energy and the growth has been mostly in analytics, and the team has done the teams have done really great stuff in that area, and that's kind of where most of the focus will be. And I'll be talking about kind of what NEUSTAR's been the area that they've been doing stuff in. So at a high level, what do? NEUSTAR tries to provide intelligent analytics to our customers so that they can better understand their customers, so they can grow their customer base, they can maximize retention and improve the interaction with their customers. So all that kind of we kind of provide the data and the analytics behind the scenes kind of to solve this type of needs for our customers. And so what's really unique and cool about NEUSTAR is its OneID data asset, which is basically a very accurate, highly accurate, and very authoritative source of identity data that we can use as our base to kind of create all this different data assets that we have in our analytics. So that's kind of the foundation, is this data set that we have that we built. And there's, you can see here that, we power a lot of the top companies across different industries, from the top banks to wireless carriers to finance. So a lot of these companies leverage our data and our services, analytics, to help them in different ways. So this is, you can see here, it's, to manage all that and all that data behind the scenes, it's really, it's a full-time job. There's a lot of processing, a lot of fees that have to come in to account for it. Changes that happen all the time. People relocate, phone numbers change, all these different things are changing. So we have to kind of manage and keep all the processes and manage all that information. And then, and all that is kind of built, the data in there eventually is fed into our application that creates all the analytics that we have. But all that information has to be processed. That's a really kind of complex and comprehensive thing that we have to kind of handle and manage. And so you can see here, this slide kind of shows you kind of some of the scope of the size, the amounts of changes that happen. You can see here, billions of data, daily updates, billions of queries that have to come in. We have to track all the linkages between all the adults in the US and email addresses, the devices, and basically thousands of attributes, demographic, consumer expenditure, behavior type of attributes that we track and use all that to enter our analytics. So all that behind the scenes is just, there's a lot of stuff, a lot of data that we manage and maintain constantly and kept up to date. So there's a lot, it's just a lot of stuff going on in our foundation of our data assets. And so here and here, so I'm just going to give you an overview kind of the different ways over kind of the foundation of our corporate assets and how our clients use our analytics and our data assets. There's just a lot of different channels, and there are different ways that we kind of support our customers, and that could be through the online interaction with their customers. That's through like a web or a mobile device interaction, or it could be offline at a site location, or we help them try understand the behaviors or kind of the makeup of the customers, what type of interest they have, or help them kind of set up plan for different marketing campaigns. So there's just a lot of different angles that we use to kind of to tackle and help our customers succeed. And there's so many different ways that different customers have different needs and there are different levels and what they're doing in their analysis. So there's a little bit of ambulance here. Okay, so some of the other high level use cases that we work with is using mobile intelligence to provide more analytics and data to our customers, more insight. And this is beyond just understanding where populations, where people live and where people work. There's also kind of what do they do between work and where they live, and what malls they go to, or what transportation hubs or airports or baseball games, and what type of individuals go to different places. So what type of segments and groups attend these areas. So just an additional type of analysis that we provide so that you can do marketing different types, especially if you're doing like digital marketing, like in an airport where you have digital displays that display different advertising based on who are the audiences. So you want to tailor that based on the traffic that's in that airport, for example. So just there's different ways of different types of analytics based on where people reside, where they work, and where they kind of commute during the daytime. So and here again, we can mention our clients span almost every industry, from telco to financial to media, and we kind of work with our customers and clients to kind of better understand, kind of as a consultant advisory scope, where we try to better understand their needs and their pain points, and try to kind of work together to come up with creative solutions using the technologies and the data behind the scenes to kind of solve different needs. And so some of the main kind of business requirements that our clients ask from us is they want to, like I said, they want to basically more efficiently market to their customers. They want to select the optimal marketing channels to reach the customers. What's the best way to reach these customers? Who are these customers? And what groups and what segments they fall under? And then also, optimize if they want to open up new sites, new location, how to optimize the store locations. But all that requires, again, like really accurate data and accurate processing and lots of high-end predictive modeling to kind of come up with the proper answers and insights for our clients. So here, now I'm going to go more into the system that we have, this Element 1 application system, and kind of the technical requirements behind that are running the system. And so this is a kind of a busy slide, and so basically what I want to do here is just kind of give what I want to come across from here is that we have a very large geospatial database, and we have billions of geometries that we maintain and manage in our database. And some of these are from very simple to extremely detailed markets and areas, from like telco wireless territories, or congressional districts, or time zone boundaries. So all those have to be maintained and accurate in our environment. Then we also have we track about 1 billion mobile traffic regions that we kind of track the volume of traffic in, and then beyond that, there's a road network where we track all the, like what Giant was talking about, where we want to track the driving distance. But in order to do that, we have all the freeways, the highways, and the local roads and major roads, the ramps in our database, all the linkages and nodes between them. So those are millions of nodes. And then beyond, there's just a lot of different customer data, as well as different, like all the business points, all the business locations, and all the DPC, which is basically all the addressable locations in the country, which represent all the kind of rooftop, which could be a building, a home, a shopping center. So all that data is kept in our environment and kept up to date. And so just to think about, there's a lot of data that we have to manage. There's a lot of data we have to process, and we have to manage it securely. We have to perform very heavy analytics on our and very complex spatial calculations in many cases, and all that has to be maintained in very high performance. And our app is, because our app is an interactive GUI-based application that users perform analytics. They connect to the app, and they pan over the map. They click on locations. They get data, analytics, reports, panels get populated. So all that kind of has to happen in real time. So our application has to run quickly, to be scalable, to support on multiple concurrent uses. So all that really behind the scenes, the Oracle technology we run helps achieve all of that really, really well, and helps run our applications, helps maintain high availability, helps the security from the security, help us button down the security aspect of our application. Then we have also cloud control to monitor our environment, to measure throughput and see how things are going compared to a baseline over a period of time. So if there's anything that's that's happening, how healthy our systems are running. So that's all that from the Oracle stack that we use helps look at that. And really, one thing that's really, really powerful is you have all these very rich spatial capabilities, but beyond that, all the rich database development framework from the PL/SQL and all the high performance and online capabilities built into the Oracle database helps us build really this rich application, and helps us kind of do and solve these customers a very complex analytical processing. And so all that's really, really behind the scenes. We could kind of leverage the Oracle technology for that. And right now we're still in Oracle 12 release 2, but we'll be upgrading to 19c very, very soon. Okay, so now I'm going to go more into the spatial kind of use cases for our customers. So one thing I just want to mention, what I want to point out here on spatial data basically is I think maybe most people are not aware of this, but spatial data is really everywhere. And even if you don't have spatial polygons, or if you don't have latitude, longitudes, or specific geographic data, chances are that you have some location-based dimension to your data. So even if you have just online transactions, these online transactions are tied to some business, or they're tied to some person sitting at their computer at their home, or sitting in a cafe with their mobile device. So there's a geo extent to that transaction. And what's interesting is once you find these spatial connections, you can start really analyzing your data and looking for patterns from a spatial aspect. And many of our customers, many of our customers who use our system initially want to use it mainly for, let's say, for example, they want to analyze their customers and segment code them, and just kind of get the demographics of their customers. And so they initially they're not even interested in the spatial part. But what ends up happening a lot of times is after they start doing and start playing around with the spatial component of our system, they can start seeing a lot more insights and useful information coming back to them, because customers are not the same across different regions, and there are different patterns and insights that are particular to particular areas, and that's the insight that you get from looking at your data from a spatial aspect. And also, so finally on this slide, I also want to give out a quick shout out to the new Oracle Spatial Studio tool. This is a new tool it's a free GUI-based tool that Oracle provides, that comes with Oracle. And you can use it to easily visualize and analyze your data without writing any SQL, without writing any programming. It's just all click. You can click on the GUI, and you can perform a lot of pretty advanced things just by clicking on different functions. So it's a great tool for those that are new to spatial and just want to look at the technology and start doing stuff. It's a really powerful, a really nice tool that you should. I definitely encourage you to check it out. Okay, so now on some use cases for our clients at NEUSTAR deal with, and kind of the different ways we use spatial to kind of solve their different needs. So one common thing that a lot of our customers deal with is basically, especially if you're like a franchise or a brand or chain type of customer, like a bank branch or some type of automotive chain, or even a restaurant that's a chain, quick service restaurant chain. A lot of cases, what the clients or what the companies want to do, they want to maximize number of locations in a market to meet the customer demand in that market. but they want to do it in such a way, they want to increase the net sales, but with minimal, at the same time, with minimal impact to any existing sites that are already in those locations. And so there's different, of course, there's different ways to solve this and deal with this problem, but it's something, so there's different approaches, but one approach is to create like an exclusive trade area. And a trade area is basically an area around a location or site location that kind of that accounts for the demand, the customer demand for that in that area that site services. And so that you can, if you create these exclusive trade areas, then you can pull demographics within those areas, and then the customers or clients can tell what percent penetration, how much demand have they taken from their customer base. Are they saturated? Are they underperforming? So they can do all these kind of analysis and see the data in those things, and then make sure that the other sister sites are not negatively impacted or cannibalized by the sister sites. So it's a common thing. And in this case, we have like if you see this in this picture, we have these non-overlapping radii that we construct with a spatial algorithm behind this, spatial toolkits. And that's really nice thing about these functions. You can do all kinds of spatial manipulations of shapes and constructing, modifying, smoothing shapes, and construct as you want and adjust. And so to build and to kind of support different use cases as they come. So this is one example of that. So another kind of common need for our clients is the need to identify concentrations of households that have a high propensity to purchase a certain product or exhibit certain type of behavior. So, for example, if you're a bank and you're interested in targeting customers who have a high likelihood to purchase a savings account or CD account, and you want to identify in a market where would these customers be. So there's different ways you can accomplish this. One approach is basically taking your component geography like zip codes or block groups and just theming them, theming them and coloring them, or you can take equally sized shapes. And one of the things with these, there's nothing wrong with theming zip codes or block groups, but the only problem there is that zip codes vary in size, and so you have bigger zip codes and smaller zip codes, and a lot of times the larger zip codes will have more population just because they're larger. And so again, you can do that. It's a quick way to kind of visualize where things are, but a probably better, a more normalized approach would be to use equal size shapes. And this is like tessellations, like hexagonal grids or square grids, and you can kind of theme those and identify areas where there is higher concentrations of those customers that you're interested in. And another approach as well is to create these dynamic regions. This is something, again, it's a really cool feature that's built into the spatial and graph, that you can create kind of like this, highs and lows of an elevation map when you're looking at, mountains and valleys. But instead of using, elevation as a metric, you can use anything else. You can use the score, number of index to buy a certain type of beer or coffee or something, and you can score that and you can kind of represent that. So there's all these different tools that help our customers use our clients want to understand where these customers are or what type of behaviors, and this helps us identify and really pinpoint those areas where they are these interesting data sets they're looking for. And so this I think Giant also mentioned this a little bit about the drive time, but this is really a very important feature as well. I think like Giant was saying, just because you have two sites, you have a customer and a site, or like you have two Starbucks. You have one Starbucks that's closer to you with a straight distance, but you have another Starbucks that's maybe 3 times further away, but the one that's further away might be more efficiently to get to when you drive there. And that might be because of more efficient road network, or there might be an obstacle that's between you and the one that's closer to you. So just knowing straight distance doesn't give you the more accurate answer. And that's where drive time is very valuable in giving you more exact exact information about what it would take, because time has a lot. It's a bigger factor in dictating what store you're going to go visit. And so one of our clients is a provider of U.S. business retail listings, and they lease their listings to businesses. And those businesses, when they want to lease these listings, they want to know how many customers are there within 5 minutes, 10 minutes, 15-minute drive distance from those locations, and they can use that to kind of get a better understanding of what who can go in and how many customers can visit that site. So it's a really powerful feature. And the nice thing about it, like I mentioned earlier, the data behind the scenes is really large. I mean, if you think about all the roads in the country, and the nodes and links and the directions and speeds, and all that is this spatial network data model handles that really well, scales processes in concurrent processing very well, and creates all these. And the calculations are very intense behind this because it has to traverse all the roads to create these kind of drive times, because all the possibilities, and all that runs really quickly, really great performance, and at the same time you have a lot of again, a lot of knobs you can play with if you want to create, focus on different speeds of different times of the day, because there's rush hour, low peak times, and let's say there's some construction stuff, or you create, there's going to be some things. You can do a lot of different things with the system. So it's really very flexible, and really very powerful capability. And here I want to talk about map projection topology, another built-in capability of spatial. So basically, a lot of the data we have is stored at the geodetic level, which is basically the latitude longitudes of we take into account the curvature of the Earth, which is the accurate distance and everything. But there's a lot of application, a lot of needs that customers have where they want to basically switch between different map formats, and some of these map formats are storing completely different projections. Like for example, if you have a customer, let's say you're a quick service restaurant and you want to open up a new site, and you pull the demographics around that area, and you're happy with the demographics and kind of the demand in that area. But then you want to you're looking at particular locations, and you look at one location, and then you want to see does it meet kind of the requirements for our site. As an analyst, you're logging into our system. So you typically will do is open up an aerial map, and you want to look at the neighborhood, or you want to interact with, let's say, Google Street View, where you can see kind of how the buildings look like, how the neighborhood looks like in that area. And so all that behind the scenes, you need to be able to switch between different coordinate projections, and all that really happens very seamlessly with Oracle Spatial. So it's all built into work and move, and so that kind of solves that use case really well. Makes it very seamless for our clients. And consolidation aggregation. So this is another very important feature and capability. And for aggregating, a lot of our customers will have like component zip codes or states that they aggregate to create larger territories that they use for their marketing purposes. So that's something very common in our system, and that has to run pretty quickly. And some of these polygons become very large because of the different components that they're combining. But that works really well with spatial and graph. And another case with consolidation is really important. If you're dealing with some very large data sets, and it becomes very valuable to be able to do that to create something that's more meaningful. And an example we've had is when we dealt with the mobile traffic data. This is very detailed data. They said basically, if you look at a small market like, let's say, San Diego or something, you'll see if you put up all the mobile device traffic over a day, it's gonna basically cover the whole map with it's a carpet of blue points. And it's not really very meaningful, and it's just it's hard to kind of deal with it. So the nice thing about some of the spatial features we've used behind the scenes, what we did is basically we took that data and organized it and consolidated based on some metric. In this case, the metric was the volume of mobile traffic. So there's definitely areas in a market where there's a lot of mobile traffic, a lot of people moving around, walking around, a lot of foot traffic, and there's areas where there's almost no traffic or very little traffic. And you can kind of organize the data based on the volume and kind of and then create like something where as the density decreases, you can create more spread out points. And so we did some kind of a structure that we kind of organize and consolidate data. And now it's much more useful to our clients. They can look at it, they can see just visually where there's high density, and as things decrease in density, they can visually see that. And also when it comes for performance and processing, they can because data is consolidated, it comes back really much faster, and they can get the data behind the scenes for those areas and for the different times. So it's really a very powerful need for us. And like I said, because you're talking about so many points, billion plus to process that and everything. Oracle Spatial has been really great for that. Okay, so another thing I'd like to touch on here is trade area creation. And I think I mentioned there's so many different ways, but there's basically the toolkit that we have that Oracle Spatial provides, we use to create all kinds of different shapes, and it's really very, very powerful to do whether it's buffering, smoothing, moving around, manipulating, managing editing the shapes, and constructing different things. And that's really very helpful because there's so many different use cases that our customers have. And one common case, if a client of ours has a database of their own customers, they can use that database, that listing of their customers, to construct an area, a trade area that represents, let's say, 70–80% of their closest customers. And that will kind of filter out all the outliers. Those once in a while you may have a customer that drives in from very far away, but most of your customer majority are going to live within a specific distance around a trade area. And once you have that, then you can pull data for your trade areas. You can pull demographics. You can kind of understand, okay, what's the competitive nature? How saturated are we in that business? How well we're doing? What customers can we reach? And also you can understand better the demographic nature of your customers and kind of what their behaviors are and so forth. So it's a really nice way to look at data if you have it available. And having these spatial features, this rich spatial toolkit that kind of Jayant alluded to earlier, you can do a lot of different things. And these things it's really helpful to have this rich toolkit, because as a customer comes in and says, can I do this or can I do that? We're trying to solve this problem. It's great to have this toolkit that you can do all kinds of stuff with it and leverage, and also just make sure it runs fast and processes things in an optimal way, and make sure the data is cleansed and accurate and all that working really well. So that's really a great thing. Okay, and so because our application is an online application, like I mentioned, users connect to it and they click on areas, they interact with it, they do run analysis right there in their system. So it has to be really optimal. It has to be snappy. And as they're clicking on data and info panels are populating and they're running reports, some of these heavy processing behind the scenes, there can be some pretty heavy with hundreds of thousands of millions of rows to process for a single data value that sometimes to come back. So there's a lot of things happening behind the scenes. So performance is really critical. And this is something that's really been great for us as well. And this is something, I think since Oracle 12.2, maybe 12 actually, I'm not sure, Oracle 12, there's been this really boost in performance. Oracle's really enhanced their performance many folds on many of their core functions, across many of their core functions. And for us, a lot of our things that we do, whether we create a trade area or do some projections or drive time, behind the scenes we're actually using a variety of different functions together to construct things, to smooth polygons, to modify, to do different things with those polygons. And so the performance has been really great, helped us really improve our customer satisfaction, their satisfaction using our system, and also helped us scale a lot more, because now we can handle a lot more customer usage, more. So it's really much more scalable. So it's a great thing. That's there since Oracle 12, release 12. I'm not sure 12.2, but 12. But it's been there since that release.
Just to summarize, two things I want to emphasize on what Nick was saying. So the first is all of the functionality that Nick just clarify if necessary, but as you were pointing out, that is underlying capability that you're using that's part of the database. So all the complex processing is actually happening on the database, and it's happening on that large, multi-terabyte database that you have. And the other thing is what I want to highlight is that it needs to happen in a really short amount of time, because people are interacting with an online self-service application in order to do their analytics, right?
Mm-hmm. That's right.
Okay. So if you want to get started, we have some links these slides will be available, and there are things that help you get started. But Nick, if you want to go to the next slide.
Mm-hmm. Mm-hmm.
There is a whole host of information and resources out there, including the lab which accompanies this. So there is a section on spatial, one which talks about how to do things in the visualization, and I think Duncan will talk about that. And the other, I just realized seeing Roger's excellent hands-on, is that I can very easily add a spatial component to that. So I will add that and add it to the lab. And with that, thank you very much.
Yes, thank you so much. Thank you, Nick, and to Jayant for all this great information. It's always great to talk about all the capabilities we have in our database, and also with great partners like you, Nick, joining us today and spending your time with us to share all this great information.